Hello guys, we are going to be talking about reciprocal trig functions. So reciprocal functions are here, but hopefully y'all know your regular trig functions. So we got sine of theta is equal to opposite over hypotenuse. Theta just represents an angle. So yeah, cosine of theta is equal to adjacent over hypotenuse, and tangent of theta, opposite over adjacent. Now cosecant of theta is equal to hypotenuse over the opposite side. So it is the reciprocal function of sine. So sine and cosecant is spelled like this. So cosecant is spelled like this. All right. So sine and cosecant, they are the reciprocal trig functions of each other. Now you have secant, which is spelled like this. It's just shortened up like SEC. That's how you kind of like write it out in its short form. This is secant, and it's equal to the hypotenuse over the adjacent side. So it is the reciprocal of the cosine function, right? It's literally just the same thing, except you flip the things. Cotangent, I think y'all know what that is the reciprocal of, tangent. And it's equal to adjacent over the opposite side. A lot of times what people get confused about is they think that cosecant is the reciprocal function of cosine, but it's actually the reciprocal function for sine. It's really weird. I don't know why they didn't make cosecant for cosine, but yeah. So whenever you're thinking about secant or you're thinking about cosecant, you're getting them confused. Just know that's the opposite of what you're expecting. Cosecant goes with regular sine, and secant goes with cosine, not the other way around, okay? Just do like a little quick example. So let's say if I have a 3, 4, 5 triangle, let's say I have this angle right over here. Let's name it theta. What is cosecant of theta? What's secant of theta? And what's cotangent of theta? What's this going to be? Secant is hypotenuse over the opposite side. I mean, cosecant is, cosecant is hypotenuse over opposite side. So cosecant of theta is 5 over 4, right? Because this is the opposite side. Actually, let me label this so it's easy for y'all to see. Sometimes it helps if you're labeling things, so you just don't have to like recall that this is the opposite side, this is the adjacent side every time. You just look at your paper and, you see this is the hypotenuse, this is the opposite side, this is the adjacent side. Secant is hypotenuse over adjacent. So it is going to be 5 over 3, and cotangent's adjacent over opposite, so it's going to be equal to 3 over 4. All right, practice problem time. It's a little tricky, so we're going to go through this step by step. Find the values of the 6 trig functions, so it's talking about all 6 of these, of an angle theta in standard position. What the hell does that mean? Whose terminal side passes through point P. What the hell does that mean? Well, standard position, okay. So what you're going to know for this problem is that you're going to be creating an angle on a graph, okay? So there's an x-axis and there's a y-axis. Now, standard position just means that you're creating kind of the vertex of your angle is at the origin. So that means that, when you create an angle, right? This line right over here and this other line over here, they're going to meet at some point, right? They're going to meet at the same point. And when it's talking about standard position, it just means that they're meeting these two these two lines for the angle are going to meet at the origin, which is 0, 0. Okay, so both of these sides are going to be at this point, right? They're going to meet at the origin. Now, it says whose terminal side passes through point P. So the terminal side just represents this ray right over here, right? When you're creating an angle on a graph, so like this example, for example, what this question means by terminal side is that when you're creating an angle on the graph, right, you're going to make the x-axis the base of your angle. So this x-axis right over here, this is going to be the base of our angle. So that means that this side right over here represents the terminal side. You can think about this side as the side that you draw in order to create the angle, right? this represents the x-axis, but in order to create the angle, you have to draw this ray right over here, and that creates this angle, theta. All right, so that's like one way you can think about it. All right, the terminal side is just the side that you kind of create in order to create the angle. And we know that this terminal side passes through point P. Now we're given that point P is at 8, 15. So let's just say that this is at 8, 15. All right. And we created this angle right over here. So now what we want to do is, this question is basically asking us, what is sine of the angle that we created? What's cosine of the angle that we created? All of these trig functions. How do we find the sine, cosine, tangent, whatever, of this angle right over here? And that, at first sight, it might seem impossible, because in order for us to use trig functions, remember, we need right triangles, right? In order to use sine of an angle, you need a right triangle, right? Otherwise, it's not really going to be possible. So what we're going to do is we're going to take our point right over here, point P, and we're going to drop an altitude down, meaning that we're going to basically drop a line down that creates a 90-degree angle. And now notice how we have a right triangle. And, now, what is this length of the triangle going to be? What is this length right over here? You can think about this length as the x-coordinate. So the length of this part of the triangle right over here is 8. Because remember, this point is located at 8, 15. And you can all agree that this length right over here represents the x value of our point, which means that this side right over here represents the y value of this point, which means this side has to be 15. All right. Now, I didn't really draw this to scale. That's on my part, but just pretend this is to scale. Now, if we know two sides of a triangle, we know the hypotenuse of it, because Pythagorean theorem, a squared plus b squared is equal to c squared. So what we're going to do is we're going to add up the square of these two numbers. So we're going to square 8 first, and then we're going to square 15 second, and then we're just going to add these two things up. So this is all going to have to be equal to c squared, which is our hypotenuse side, right? A squared plus b squared has to equal to c squared. All you have to do is just take the square root of both sides. So then you get c is equal to 17. You might be wondering, if you're taking the square root of this part, it doesn't have to be plus or minus. It doesn't have to be plus or minus 17. But your side of this triangle right over here, well, it can't be negative, right? So, right, the c value right over here, it can't be negative. So, yeah, you're only sticking to the positive answer. So we know that c is equal to 17. Now that we have all the hard parts done, now the rest is easy. So what's sine of this angle that we created right over here? Well, we know that sine is equal to the side opposite over the hypotenuse, right? So sine of theta is going to be equal to 15 over 17. Cosine of theta is adjacent over hypotenuse, 8 over 17. Tangent's opposite of adjacent, so it's going to be 15 over 8. And then that is the ugliest. Wait, what? That is the ugliest 17 I've ever seen. What is that? That looks like pi. All right. And for the reciprocal trig functions, it's literally the exact same thing as the sine one, except you just flip the numerator and the denominator. So cosecant of theta is going to be 17 over 15, right? Because cosecant and sine are their reciprocal trig functions, right? So cosecant is the reciprocal of sine. Cosine, we know that's 8 over 17, so secant has to be 17 over 8. Tangent is 15 over 8, so cotangent has to be 8 over 15. Right, it's just going to be the same thing but flipped. And because, just like a little quick reminder, because these two things are reciprocals of each other, that means that cosecant of theta has to be equal to 1 over sine of theta. Alright, if you don't get that, you can plug in the formula and y'all can check for yourself, right? So sine of theta, we know that's opposite over hypotenuse, right? So let's substitute that in here. 1 over opposite over hypotenuse. cosecant of theta, we know that's hypotenuse over opposite. So doing kind of a little bit of algebraic manipulation, we can rewrite this as 1 divided by opposite over hypotenuse, right? We can rewrite this as this. 1 divided by opposite over hypotenuse. Keep, change, flip, right? Because it's a fraction. So keep, change, flip. And 1 times hypotenuse over opposite is just hypotenuse over opposite, which matches up with what cosecant originally was. So cosecant is 1 over sine of theta. Secant of theta is actually 1 over cosine of theta. So it's just going to be 1 over and then the kind of reciprocal of that. And then finally, tangent of theta is equal to 1. Finally, cotangent of theta is equal to 1 over tangent of theta. And there you go. So those are also, find the values of the 6 trig functions. It's literally the same problem, except that our point is now 5, 5. So how do we do this problem? And before we do that, I'm just going to copy, paste, boom. All right, so how do we do this problem? Remember, standard position just means that the base of our angle, which you can think about as the x-axis, and the ray that we use to create the angle, so the ray that we draw in order to actually create our angle, they're going to meet at the origin, 0, 0. And the terminal side of our angle passes through point P. Passes through point P, which we said now was 5, 5. So this is point P. Now, in order to solve this problem, right, in order, to solve for sine of theta, cosine of theta, whatever, we need a right triangle. So what we're going to do is we're just going to draw this altitude down, create a right angle, and we have this makeshift right triangle. Our x value is 5. So this value right over here has to be 5, right? Because 5, 5, well, this represents the x value of our point, right? So this has to be 5. This represents the y value of our triangle. So this also has to be 5, because it's 5, 5, right? Now, if y'all don't know this, basically, what we have right now is a 45, 45, 90 right triangle. I'm sorry if y'all don't know this, because I'm kind of throwing like a lot of concepts out here, like terminal side, whatever. So if y'all don't know that, I'm pretty sure I have a video on 30, 60, 90, and 45, 45, 90 triangles. I also have a video on like unit circle and stuff, where it's like a very similar concept, right? You drop an altitude down to create the angle. So go check that out. Basically, x, and then the hypotenuse is x radical 2. So if both of the smaller sides of your right triangle are the same size, so if they're the same value, that means that your hypotenuse is radical 2 times longer than both of those sides. So in this case, our hypotenuse is going to be 5 radical 2. And now, right, this is the opposite side, right? This side is opposite this angle. This is the adjacent side, and this is the hypotenuse. So now we are just going to do some math. Sine opposite over hypotenuse, that's 5 over 5 radical 2, or equal to 1 over radical 2, or we can multiply this top and bottom by radical 2 to rationalize the denominator, so we get it's radical 2 over 2. We're multiplying the top and bottom by the same number, so this is still equal to this. Cosine adjacent over hypotenuse is just going to be equal to 5 over 5 radical 2, which is going to lead us to the same answer. Tangent is opposite over adjacent, so 5 over 5 is just 1. And cosecant, well, it's just going to be the opposite of what we have here, so it's just going to be 2 divided by radical 2, right? Because this right over here is the value of sine of theta. That means that cosecant of theta, well, we know it's literally the same thing, except you just flip this fraction, right? You just flip the opposite over hypotenuse part, right? So it's just going to be 2 over radical 2. We know cosine of theta is equal to radical 2 over 2 in this case, right? Because it's the same thing as sine of theta. Sine of theta in this case and cosine of theta are the same value, right? So that means that secant of theta has to be 2 over radical 2, right? And finally, cotangent of theta, this is just going to be 1, because we said how tangent of theta is equal to 1. So that means that if we flip this fraction, 1 over 1 is still 1, right? You can think about this 1 right over here as 1 divided by 1. So if we flip this fraction, it's still going to be 1 divided by 1, which is 1. And there we go. That is the answer.